Chapter 9, we are going to learn a process called hypothesis testing. So I told you that second semester revolves around the same two processes. The first one you've already learned, and it's a confidence interval. The second process is called a hypothesis test, and as you can see at the top, you are testing a claim. So in the first section, we're going to learn the background, and then we will learn how to do it for proportion and how to do it for mean. It is going to involve the 4 C's again. So we're still going to choose what process we're going to do. We're checking pretty much the same conditions that we did before. We have some calculations and a conclusion. So it's going to be very similar, just the difference being we're testing a claim instead of coming up with an estimate. I'm going to ask you to skip the multiple choice and find section 9.1, which looks like this. All we're going to do is the first problem together, and this is something that we've talked about already. We've done examples with before. We're just going to look at a quick review. A recent study on the relative age effect and career success, evidence from corporate CEOs, suggests that people born in June and July are underrepresented in the population of corporate CEOs. This is consistent with the relative age effect due to school admissions grouping together children with age differences up to 1 year, with children born in June and July disadvantaged throughout life by being younger than their classmates born in other months. In a sample of 370 corporate CEOs, bless you, only 12% were born in June and July. Is there convincing evidence that the true proportion of all corporate CEOs born in June and July is smaller than 2 out of 12? Okay. So if all of the birthdays of corporate CEOs were randomly distributed, we would expect out of a sample of 375 that about 2 out of 12 of those CEOs would be born in June and July. Just so you know, 2 out of 12 is about 16.7%. So that's what we would expect. We would expect if all of the birthdays were evenly distributed, about 16.7% of corporate CEOs to be born in June and July, but we only got 12%. So, is there evidence that people born in June and July are underrepresented? Yes, because the sample proportion of that 0.12 is less than 2 out of 12. So we expected 2 out of 12, we took a sample, we got a number less than 2 out of 12. Does that mean definitively that people born in June and July are underrepresented? No, we've talked about that. There are 2 possibilities. What is one possibility for getting a number that is less than 2 out of 12, or a sample proportion less than 2 out of 12? Variability. Could it be true that 17% of corporate CEOs are born in June and July, and we just happened to take a sample where we got a small sample proportion? Yes, of course. So first explanation is there is no disadvantage. The lower percent is due to chance alone, or like Augie said, sampling variability. If that were the case, the true population proportion is that 2 out of 12. Ireland, can you see with me standing right here in all of these books? Okay. So that's the first possibility. The other possibility that we've talked about is that there really is a disadvantage. So the other possibility is that people born in June and July, those people really are disadvantaged. If that were the case, then the population proportion of corporate CEOs born in June and July would be smaller than 2 out of 12. So that's what we're trying to decide between. Is it true that the population proportion is 2 out of 12, or is it true that the population proportion is less than 2 out of 12? So the big question is, how do we decide which of the 2 explanations is more plausible? We will not be able to determine which one is correct unless we actually talk to every corporate CEO or get all of their birthdays, but we can figure out which one is more plausible. The way we do that is we determine how likely it is to get a sample proportion this small, so that 0.12, by chance alone, assuming there is no birthday disadvantage. So assuming that that population proportion is really 2 out of 12. So when we say determine how likely, we mean find a probability. We don't know how to do this by numbers yet. So we don't know how to do this by numbers yet. What we've done in the past is we've looked at a simulation. So we're not actually going to do that, but I'm going to tell you how it would work. We would use a simulation. We would use the numbers 1 to 12 for the 12 months. It's a sample of 375 CEOs. So we would generate 375 numbers for the 375 CEOs. And what we care about is what proportion were born in June and July. So then we would go through those 375 and we would record the 6s and the 7s. So those are the ones born in June and July. Now, if you remember, when we've done this in the past, we've looked at a whole bunch of simulations, not just one. So you would tell a computer how to do this. And you would tell the computer, spit out 1,000 different possibilities or 1,000 different samples. And so then if you remember, we would have a dot plot that has a whole bunch of sample proportions. Right, and I don't know where there'd be a whole bunch of them though. Let's say maybe 1,000 sample proportions. And to figure out how likely it is to get this sample proportion, we would find our sample, 0.12. So maybe that's here. Remember, though, we never find the probability at just one specific value, so we would find that and everything below it. Now, it says, determine how likely it is to get a sample proportion this small. That's what we did, assuming there's no disadvantage. That assuming there's no disadvantage comes from this simulation. We set up our simulation so that there is no disadvantage, that every month is equally likely. Again, we don't know how to actually calculate that yet, besides with a dot plot. So, last thing that I need us to get from this is how else we could have estimated. So how else can we estimate the probability? Besides the simulation, we could look at a sampling distribution. We've done that. Calculate what is the probability that p hat is less than or equal to 0.12. We did that in chapter 7. The other way is we could have looked at a confidence interval. So we could construct a confidence interval and ask, or see, is 2 out of 12 reasonable based on our interval? So this is the idea of what we're going to be doing moving forward. Just give me like 30 more seconds to talk. We are going to have some claim, and we are going to be testing a competing claim by figuring it out how likely it is based on a sample. Questions for me?